This week, a visit to a high-tech machine shop to see the prop shaft getting made. Then back in the boathouse, Steve and KP cut out the holes for the port lights before fiberglassing the housetop. But before Ann headed off to New Hampshire to take care of the prop shaft, Steve needed a few more measurements to provide the machinists at Accutech. When it comes to hoisting something like the rudder into place, Steve's rock climbing background and equipment has come in very handy.
Okay. That's all I needed. Can lock those.
Neat. These have little brakes on them or something?
Yeah, it's a toothed.
Oof, nice.
How are you? Thanks for coming. Steve's rigging up for, we're gonna kind of lift the rudder into place in a little while. So he's deep in thought, making sure he's got everything all set to keep everyone's head safe.
The last I saw was him taking a jigsaw.
That's, yeah, well, you know. Yeah.
We did this a couple times with just one other person. It's a lot easier.
Watch that prop.
Yeah. Okay. Yep. Perfect. Thank you kindly, folks.
Nice.
I believe I can take it from here.
So I'm about to round a corner here to go to Accutech Marine Propeller here in Dover, New Hampshire, which is also my hometown. It's nice to visit here, to the other places, but also I'm really excited about meeting some people who are very good at what they do and to see some really cool specialized tools. All right, let's go check it out. I know this guy.
Hi.
Let's go have a look at the shop.
Sure, let's look at the shop. Come on in. We have approximately a 5,000 square foot facility that I started in 2001. And we work on everything from small propellers, outboard propellers, up to large inboard propellers. This is actually for one of the boats that's on the Wicked Tuna Show, tuna.com. We have machining capability to make the shafts, which is why you're here today. And we'll walk through this way and I'll show you some of what we do. We do have other CNC machining capability that we make specialized parts with, such as prop pullers and other items that we find that we need. We make a lot of our own tooling. For example, these balancers, which are rather simple, we make all of our own arbors. We've made these balancers. All these tables that you see have all been custom made. There's no There's no store that you go to buy this stuff. It all has to be custom made.
Acutech is known for their propeller services and are able to take measurements from damaged propellers using their prop scan technology to make a precise replica. But we are here today to have them make a prop shaft for Arabella.
I'm Brad, machinist here at Acutech. Been here about a year and a half now, and we're going to start off making the shaft for the boat. So we're going to take the shaft, got the bar stock here, I'm going to take it and put it in the lathe, we'll face off the end, put our center drill in, set up our tools, and we'll run the program. CNC lathe is computer controlled, uses system G code for dimensions, and you can pretty much make anything you want in a two-dimensional fashion. Z0, turn on the coolant, then I'm going to let it cut. And we'll make about a 200 thousandths deep center drill. So the machine's going to cut the rough and the taper right now. It's going to cut that in steps. So now we just switched tools and now we're finishing it. So it's going to be a little bit lighter of a cut. You can see the smaller end here is where the threads will be. You can see we already have our taper. So now we're doing the undercut for the threads here. Alright, I'm going to clear that chip. Just change tools to the threading insert.
Oh, I saw that. Did it lickety split?
Yeah, it's quick.
Oh my goodness. Yeah, you're not handling that with your hands at all.
No.
He's learned that.
Yeah, the hard way. This is the coolest part, I think. We'll probably have to rerun the threading insert, make another cut, because we want to make sure this fits. If that doesn't fit, that's going to be a problem. Let's see. Nope. I expected that. So now I'll make it's called an offset on the tool. That just tells the machine basically to cut a little bit further next time we run it. Sort of changes that geometry just a little bit. There we go. All right, let's check it again. I think that'll do. There we go. That's the prop end. There we go. All right, so now we're going to cut it to length. So I already got the length measured out. We'll just start this off. getting there. Got to cut to length. We'll face off the end, put a little bevel on it, then we can fit the coupling. Well, you might have to take a couple cuts to get that flat. Arabella is going to have a split coupling, so we're going to have to take out the bolts. We're going to have to put wedges in and open this up a little bit so we can actually get it onto the shaft. Alright, so take it back to the lathe. You want a snug fit. I'm not tapping that very hard, just a little bit. We'll have to spin up the lathe and use a piece of sandpaper to sort of sand the end down just a little bit. Don't do this at home, kids.
These are really delicate taps. He wants to be able to tap it on and tap it off.
So you want the end of the shaft to be flush with this face here. And we're there. So the couplings fit, and now we can cut the keyways. All right, let's go set up the horizontal mill. This is used for, you can cut keyways, you can cut gears, spline shafts, a lot of different things with this. Tighten this up. All right, so now we're gonna put a piece of, we're gonna use actually the end cut off the shaft, and we're gonna use that to center the tool and make a test cut. That way I know everything's ready to go before I actually cut a shaft. All right, we're at 0. All right, so now we'll just make a quick test cut. Doesn't have to be very deep. So there's our test cut. And if we weren't on center, you could see the radius of that cut would be uneven. So, looks good to me. Now we can actually cut the keyways in the shaft. All right, so we're gonna do the prop end first, and we need to get this taper level. I'm actually gonna use, there is a more accurate way of doing this, but this digital level box gets us well within the tolerances we need for a keyway. Okay, wow.
Where did you eyeball that?
I got lucky. That doesn't usually happen. Once the cutter gets to that Sharpie line, that's where I'll stop. Because the keyway does not need to go past the end of the taper. All right, we're almost at the end here. All right, that's the prop end. Well, we can take it out and we'll do the coupling end. I want to keep the keyways in line with each other, so I'll just use a level on this end. All right, there we go. Almost there. 78 thousandths. All right, 159. Perfect. Keyways are done. So now we need to make a key for the coupling end. I have some key stock over here. I already have it marked out. Just gonna cut it on the bandsaw. Some of the lower unit repairs that I do.
Oh, there you go.
This one had a big chunk missing and I welded it back up. Still needs finish work, but check and see if it fits. There we go. Look at that. Perfect fit. So now we're going to take it, we'll put it in a smaller lathe. And we're going to put the coupling on, and we're just going to reface off this face, which is what will bolt to the flange of the transmission. All right, so now we just have to, we'll do a little dimple for the set screw here. Now we can put a cotter pin hole in it in case you guys do decide to ever put a fixed prop on it. And that's it. Here's Arabella's shaft.
So unlike a fixed propeller like you see here, Arabella will have a variable pitch propeller that allows the blades to go into a feathering position when under sail.
All right, let's take a look and see what your new prop looks like. Get your instruction manual. Okay. Here's Arabella's new prop. These tapers are done to a 1 in 16 SAE tolerance, and the same in the propeller. What's required is a minimum of a 70% contact on here. We shoot for over 90%, closer to 99%. So we'll see how this actually fits on there. Okay. Propeller fits. There's no wobble, there's no play in that at all.
There you go.
All right. The nut's going to go on like so. Now we're not going to tighten it down like we would if we were putting it on the boat, so we just want to put it on here, make sure that everything's nice and snug the way it is and it's perfect. Now one of the tests to make sure that it's correct is can't get it off. So now what we're going to do,
There you go.
is with a dead blow hammer just gently. There it is.
Perfect fit.
Everything fits the way it's supposed to.
Here's the winter enclosure. It's warm in here, but not out there.
All right, you think we can flip it in here?
I'm very curious about that as well. I don't know.
It's gonna be really
It's
tight.
gonna be close. It's gonna be rough. Just a little bit.
Oh, I think we'll have it.
So we can lower. You good?
Yep.
Sweet. our winter warmth plan. It's hard to view if you visit. So, Steve, what are you doing?
Now we can really feel like zoo animals.
Please do feed the animals. We like donuts, coffee, meat sticks.
I mean, it's a little wonky because it's wavy.
Sure.
But
What happens if you knock on it? Yeah, that seems
yeah,
right.
please don't do that.
We're getting ready to fiberglass the house top. Finally. Before we do, we've marked and set up locations for port lights, as you can see here. So it's time to cut big holes into the side of the house. That's glass.
We still got to cut out the ones in the forward part of the house.
Forward too.
And the one here on the side.
Oh, that's right, the little propane
The big
tank.
deck plate.
Cool.
2 more. I'm almost done nailing the lid on.
Nice. Oh. It's nice and warm in here though. My new kicks. First of all,
Oh, the big drill?
Yeah. I couldn't get Joe to say it again, but he said that when he worked in shop, there was a guy who ran one of these drills.
He was usually short
And he was usually short and had one big arm.
And he sat on a stool.
And I'm imagining this fiddler crab of a man.
And he sat on a stool. Yep. So
and this beautiful Italian thing, I just need to know more about it.
this is a very old case or radial drill. And I really don't know when it was built, but I would say probably, say in the late 50s, early 60s. And I found it in a machine shop in Massachusetts, and it had been in storage for a number of years. I was looking for something that we could use to bore to enlarge bores on propellers. And so we have special reamers made, and they fit into this. But this is this is an oldie but goodie. And we have multiple speeds. It's like a Ferrari gear shift here. We have multiple speeds, and we can move this in all kinds of directions, in and out. These are the cutters that we use, and they're specially made for the propeller tapers. They're not a standard Morse taper, they're 1 in 16 taper. These, very expensive, but they do the job. And these fit into that drill press, and we'll just run it down and enlarge the hole. And then we have a special key seating machine that uses a different cutter. You see, we have different sizes for different bores.
They're amazing.
From small ones to really large ones. And the cutters that we use, these cutters are used for putting the keyways inside the bore of the propeller. And I have a special machine over there that these lock into, and they go up and down, and we actually cut the keyways. It's not new technology, it's very old. But what it does is, the cutter fits vertically in here, and we have special adapters that go on here. The propeller sits on there, and the motor driven, we lock the propeller down, and the key cutter moves up and down, and we're able to move the table to cut into the propeller.